Okay, welcome back. We're kind of talking about a philosophical discussion of using the three-tier architecture. Now, admittedly, you don't have to use that for every application you write. But on the other hand, if I'm telling you like in an assignment that I want you to use that technique, well, then you might want to be paying attention to this. So what I'm going to have to do is go to my employee class, and any place where I have a standard, system out or a system in or a system error, I got to take that out. And you think, well, wait a minute, how the heck are error messages ever going to get back if the employee class isn't allowed to talk to the user? Well, the way we're going to do it is we're going to throw our own exceptions. Okay, so let's just go through the list and see if we can find the very first one, and we'll fix it. Okay, here it is. So this is actually going to be kind of sort of easy. I'm going to use the throw keyword. I want to throw an exception, and then I'm going to create a new exception object. New exception. Okay, well, I got a red squiggly, and you think, oh, I must have done something wrong. Well, not really. It says unreported exception must be caught or declared to be thrown. So one of the things that you do here is add throws clause. So I'm going to do that. Now, what that basically means is this is telling the system that when you use the set first name, there is a possibility that it might throw an exception. Okay. And by the way, remember now that it breaks a sequence, right? So there's no reason for this return statement anymore, because if it throws an exception, it's never going to go there. So I don't need that statement anymore. Isn't that pretty cool? All right, the others are going to be almost exactly the same. In fact, I probably could do a little bit of copying and pasting here, right? It'd be throw new exception. Get rid of this guy. Dang, I cannot make the mouse work today. And then I need to put that thing at the top, but I'm going to have the machine do it for me because I'm lazy. Okay, cool. Let's do it again. There's only a few of them, so this is not going to be too boring. Throw new exception. Get rid of this guy. And then annotate the thing here. Now this throws keyword is new. We haven't talked about that yet. Just bear with me. All it says is be aware this method may actually throw an exception. Okay. I tell you what, I'm going to do the rest of these off camera, so to speak. But let's do pay count. That's a good one. I'll do one more. So I'm going to go here and say throw new exception. Whack that guy. And then, of course, it's going to have to say, but wait, you need a such and such. Cool. Now, pretend like I did all the rest of them, because I don't want to waste your time. So now, if I go back up to here in Java world, well, actually, no, let me just hit compile and see if there's an error in here. Why, yes, there is. And it tells me on line 61 and 62, there's a potential problem. So if I go up here to line 61 and 62, it's like, hey, remember, these things could throw exceptions, right? They could throw exceptions. So how do I deal with it? Well, basically what I'm going to do is I'm going to add a throws clause up here. Now, the throws clause does not make the exception go away. It's just a warning that whenever you run one of these methods that you're going to have to deal with an exception. So let's go back. Okay. So now I'm going to create me a brand new employee. This is the way we've always done it, right? We've done like, well, dang it. I need a, okay, let's just do, dang, employee is equal to new employee, and the first name is Bob. The second name is Smith. And the third is employee depth type, I don't know, sales for no particular reason. Okay, I'm done because we've been doing this all day. What? I got a red squiggly? What on earth for? let's go see. It says, hey, an exception might be happening here. Oh, so now I have to put this in a try block. Okay, that kind of makes sense. Because before they never threw exceptions, but now they do. Because we went in there and we marked it up. We changed all of the system outs and we changed them to exceptions. Okay, see how we did this? This is how big boys write application. When you're writing a business logic layer component, this is how you do it. And you force the person who's writing the user service layer, in this case like the Chapter 11 Java file, you're forcing them to deal with the exceptions that are thrown in the other one. Okay, that kind of sort of makes sense? Okay, good. So, the idea behind all this is separation of duties. I am going to go back to this. It's not something we're going to be testing you on, but beside the point. So here, in Chapter 11, this is where I do like the prompt for integer, or prompt for string, or prompt for enum. And down here is where I do the error in the setters and in the methods, right? Because we did all, well, I didn't do all the setters, but it will be when time you look at it. The setters throw exceptions, and the method, the only method we had was CalcPay, and it could throw an exception, right? So that's how this thing is designed to work. Okay. Whew. All right. So, if I throw an exception, well, okay. So, the throws keyword is a warning to you. The throws keyword is a warning to the system that says, don't ignore me. I may have a problem. That's what that thing means. So, typically you add throws when you want to pass the buck. I don't put the try here, okay? I mean, I could, but I don't want to handle the exceptions in the same layer that I'm generating the exceptions. That would kind of be defeat the purpose, right? So this second layer generates exceptions, but doesn't handle any. And this is the top layer, and it does handle things. Of course, you can create some exceptions here. Okay. Now, hopefully this made sense. When you go back and look at the lecture notes and see how this thing works, is all I did was just convert all of the system error to, throw new exception. That's all I did. Okay, and made it so that every time you do this, likewise, if I was to go in here now and try to do something like CalcPay, the CalcPay would also have to be inside here. Okay, this guy. Because it throws an exception too, remember? Cool. And in fact, in this case, it is going to throw an exception because of that state validation guy, that sanity checking guy. In fact, let's just see what it says. So I'm going to go ahead and say system.err println, and I'm just going to be lazy and just say toString because I don't want to spend too much of your time watching this goofy video. Now, I know there's going to be exception. Exception is not going to be on line 78, because that's okay. The exception is going to be here. Do you remember why? Let's go check. Oh. That was not what I was expecting. Package system does... Oh, I didn't spell it right. Okay, let's try that again. Oh, I still didn't spell it right. Ha ha ha. Hey, me and my typing skills. Aren't you glad? You're not getting graded on dang it, man! I'm having fun today. Let's get the cursor down here, doggone it. 42. Yeah, we got a problem with that. And then it says something went wrong, and then it says Java language exception value for rate is not set. That's the guy that got thrown because of the sanity checking in CalcPay. Okay, because I didn't set the pay. All right. I'm sorry, I didn't set the pay rate. Okay, is this making sense, guys? Okay. That's basically all there is to know about exceptions. So you need to know how to do a try, a catch, and a finally. You need to know that there's multiple catches, and you have to have them in the right order. You need to know about the idea of, some layers are designed to throw things only, and some layers are designed to catch things only. Okay, things like that. That's about it. The throws keyword is an indication that you're going to have to deal with it. And then throwing a new exception. Okay, good. So now we're going to change gears completely and start with binary files on page 732. So you might start off with is, well, wait, what's the difference between a binary file and a text file? Well, binary files store numbers and text as bytes, not something human readable. And that's actually a good thing because the text files can get kind of large. If I was to store, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? That's quite a few characters, believe it or not. If that was a binary file, it would be much, much smaller. So instead of having, like in the case I just gave you, 9 bytes, 9 numbers, 9 integers. An integer's probably gonna, 9 bytes. 1, 2, and a 3, and a 4, a 5, and a 6, a 7, 8, and a 9. Okay, so 9 bytes. But I could store that in a file with an integer is only 2 bytes long. I store it in 6 bytes because it's just integer first one takes 2, integer second one takes 2, right? So I can really cut this thing down by reducing the size. So binary files are good because they're smaller and they're faster to deal with. The disadvantage is I can't open them up with Notepad and see what the heck's going on because it's all gobbledygook. But I kind of like that. So why would you want to use a binary file? Well, speed and size. Okay, so there's 2 classes for doing writing to a binary file. There's a file output stream and a data output stream. And so this is very analogous to the way we've done other types of file open stuff. If you remember the print writer guy, okay, this is practically the same as a print writer. Okay, so let's, for example, I'm going to start typing and I'm going to say file output stream, and I'm going to call this, I don't know, FOS because I like abbreviations. Then I'm going to say new file output, dang it, stream, and then something like my data file. Except this time I'm going to call it DAT, which is kind of a convention to let you know this is data rather than text. So obviously I'm going to need some include files. Yeah, that's what the little thing here is. Yes, please do an import for me. And then I have an unreported exception. What's going on? Well, this thing could throw an exception, couldn't it? So every time I do one of these guys, I'm going to have to wrap it inside a try. Okay, this kind of makes sense now. Because inside this guy, it has one of those throws. Now, we didn't write it, obviously. But inside this guy, it has its own throws, which means I had to deal with it. So when I first started typing it, I had 2 things that went wrong. One is I had to do an import. And the other one, it says, hey man, this thing throws something, so you need to deal with it. Cool. Okay, so I did. Okay, we're coming up on the 15-minute mark. We'll finish this off in just a few.